Welcome to Calculus.
We've always been good at math. How hard could calculus be?
On this episode, Stevenson will demonstrate.
The region between the graph of f of x equals 2 plus x cosine of x and the x-axis over the interval from -2 to 2 is revolved about the x-axis to generate a solid. Find the volume of this solid. So here's a picture. Now when you're asked to find the volume of something that's revolved around an x-axis, what happens is it creates what's called a solid of revolution. So what this means, according to our text, and you have this in your notes, is what we're going to look at is the area of the cross section multiplied by dx, and the dx is the thickness, and then we're going to go from A to B. Now in the previous video, what I showed you is when you try to find the volume of something that's been revolved, the cross section itself is a circle, and the thickness is dx. So ultimately, you're creating a cylinder. Also in the book, when you are doing some kind of solid revolution, you're creating what the book calls is a disc. In the previous video, I called it a cylinder because of the shape it creates, because it's a circle with thickness. Use either word, it's fine. I just wanted you to be familiar with the vocabulary. Now, the f of x function right here is actually this function right there. So this is the function f of x, and it has been stopped from -2 to 2, and it is being revolved around the x-axis, as you see right there. So we need to try to make sense of this problem of what's going on. So the first thing what we want to do is get an idea of what's our cross-section look like. We know it's going to be a circle with thickness, so we know it's going to be a cylinder. So let's try to make sense of this. So if I draw my rectangle here, its base is dx. Now it's rotating around the x-axis, so we know it's going to create some kind of cylinder. It's going to have a radius, we know that, and the height is going to be dx. So what is the volume of this slice? Well, we know it is a cylinder. And we know the volume of a cylinder is the area of a circle times its height, right? Well, in this case, the radius is going to be the function f of x. Now, what's the height? The height is dx. So for this problem, really the volume of this one slice is going to be... But remember, we don't want the volume of just one slice. We want all the slices from -2 to 2. So we want the volume of the total solid that is created by revolving this shaded region about the x-axis. So we're going to integrate or accumulate all of the little cylinders, all those V slices, from -2 to 2. And this is the volume inside here. Or this is the integrand right here. Given what this is at this point, you're just going to put this in your calculator.